15 minutes. This will be like a presentation of my presentation. So you will find the slides and the paper on my webpage if you're interested in seeing the slides in full. So this is joined with Gerlagh and Vehvilainen. And Ivo is the kind of the industry expert here. This is related to electricity markets, the talk. I'm somewhat between the fields, and Reijer, many of you know Reijer is a genius. Shortly. Let me give you a little bit of context what this paper is about. Here what we have is contract prices during the European energy crisis for Germany and France, and these contracts are for the year 2023. And you can think about, if you look at 21, that the relatively low prices were expected to prevail in that year 23. And then when the crisis in Ukraine unfolded, you see that the contract prices gradually start increasing. And in particular, we started writing this paper, by the way, in the spring 22, when we realized that this thing is coming. And this was initially a sort of policy brief, but it became a bigger paper then in the end. And I'm presenting the bigger paper, or sort of give you a spiel about it, and then you can have a look at the paper perhaps. You see also the gray line, and the gray line is a little bit shaded area. That tells you, if you think about what is the marginal cost of the marginal plant, which is a gas-fired power plant. And you can think about that the gas cost is also contracted. So you see that this kind of unit is expected to get some margin there, because the price is higher than the unit cost. You can think about sort of owning this plant, and you are selling the output already in the summer of 22 to the winter, and you contract the cost of producing that output, and then the difference between the output price and the marginal cost tells you the margin. And I show you here that same story in another graph, because that tells you what is the markup over marginal cost in these two areas, France and Germany, and how it unfolded when the crisis was developing. You see that something happened in the spring 22, and what happened was that in the market we hit the price cap. Because I want to kind of communicate what is the institutional framework in Europe, is that you have a common price cap for the electricity wholesale market in Europe, and there's a rule that if you hit the price cap, then you lift the price cap up by 1,000 euros per megawatt hour. And that's what happened in the spring 22. And then the market was expecting this thing to happen perhaps many times before the winter is really coming close. And you see that the markup was over the marginal cost was increasing then with this because of these expectations. And what this is reflecting is that the market was really expecting that the prices are no longer determined by marginal costs, but by scarcity. That you are expecting to hit many times the price cap, which was now 4,000 euros, like 100 times more than the normal price. And that thing kind of went on until in the late of the year. Then finally the regulators understood that this is not going to work very well. So they kind of removed the policy of lifting it up every time you hit the current price cap in the spot market. And so therefore the market was no longer expecting these prices to go kind of off the roof. But nevertheless, kind of tells you already that this is a very, very important policy decision, how you decide this price cap, and it's it has big impact on how much consumers were paying for the electricity, because contract prices were often linked to these contracts what we observe here. The winter was not so bad, but this was what was expected. So the questions, this is probably giving you enough context that you understand that this is a very important policy question, that what this price cap should be. Is this price cap that we saw, was it misguided? Certainly it was, because had it been the case that we are paid the price in thousands, then we are spending like 100% of our GDP on electricity, and that's not going to be sustainable. So clearly it was too high. But what should be the procedure for updating this price cap? More generally, do we need a price control policy at all? Many economists argue that no, we don't need, because that's going to create like the missing money problem, that the price cap itself is the source of the problem, that the firms are not investing and to solve the scarcity problems that are in the markets. And of course, if you set the price cap too low, then certainly that problem will arise. But what we argue in this paper, that solution is not to leave the market completely without a price cap. It will be, according to our paper, efficient to have a price control policy in place. And I'm saying efficient. We have no distributional concern. We have no political economy in this. We're saying that just using basic price theory, we're showing that it is efficient to have this price control policy in place. And I can tell you, because we have like this 15 minutes, I tell you the results right away. The reason is that we have a market institution that is pooling under one demand curve in the market all kinds of demands. Price responsive demands and sticky demands from those customers who are not responding to prices at all. And the market distortion is right there. Because in an efficient market, these different customer groups should see a different price. But when you're pooling it together and when you're in a uniform price setting, you need a price control policy in place to correct for the distortions that are created by this market institution. And this is the market institution. We have the uniform price setting throughout Europe and in many other places as well. In our setting, because in our first policy paper was basically just showing this argument, but then people were asking that, but what happens to the investments and so on. So in this more sort of comprehensive paper, we have the investment decisions as well. And we model how the demand is built from private decisions. Private decisions are investments into technologies that allow you to be price sensitive, while some other people find those technologies way too expensive and they will not invest. They are still rational. They invest in some other technologies, for example, heat pumps and those things that often kind of you can understand rationally, you can form the price expectations and you understand what the technology is consuming. But when the spot market opens in any given hour, it's not going to be able to respond on spot. So as long as there's a fraction of consumers like that, so part of the demand will be sticky and you will have this problem that the spot market demand will not be reflecting the true social cost of consumption or true social value of consumption. So and if you don't have the control policy in place, the market allocations are inefficient, investments are inefficient. Firms will over-invest to hold idle capacity to solve the problems caused by this sticky demand. So you need the price control policy to solve for this missing demand response. And it could be also behavioral reasons that are behind this sticky demand, but on purpose we model it in a way that consumers do not have behavioral biases to show that even if you're able to correct for the behavioral biases, the argument remains for this price control policy. So what we do is that we show how you can derive this optimal policy from a market where you observe bids to sell and bids to buy. And we show how you can implement this in an actual electricity market setting. And we use Nordic power market to quantify the meaning of this policy proposal. So maybe I'll just move on. The model, we have a model, but I'm not going to be able to very much talk about it. There will be a model. And the model is one where the timing is such that you set a policy rule first. So you tell what kind of policy you will have in place to control the prices. And then we allow firms and consumers to invest in technologies. So and these investments will then kind of build the supply curve and the demand curve. And then the market clears in the final stage, taking into account what is the policy rule and the investments that have led to these demands and supplies. So I'll show you something about the model that you have, thinking about the last stage where you've already made the investments and you observe the demand curve and the supply curve. So when you observe these, they typically are different in different states of the market. You can think about the temperatures and weather conditions are having an impact on what's the demand, and also supply. There are different supply states depending on how much Russia, for example, is limiting supplies of gas to Europe and so forth. So, and we assume that the market participants understand the distribution of these states and how they interact with demand and supply, and they understand that there's a policy rule And the policy rule is such that it rations demand on a pro rata basis. So you have the observable demand. We assume that the policymaker observes the whole schedule of demand, which is what you do in power exchanges and commodity exchanges in general. So this is coming from the bids to buy. And you apply a rationing rule where you do that rationing in a pro rata basis, that you take parts, the same fraction of demand at each price level. And this is how it's actually done in practice. So we are not sort of inventing this, but because we are in this current market architecture, sometimes we are hitting the price cap, and then you need to implement the rationing, and this is how it's done. And then, if you submitted a bid and you're getting rationed, you're not getting from the pool exactly what you were asking for. And then that problem goes on, and the DSO is solving this problem in different ways in different places. But typically they have their own reserve capacity to deal with the problem because the quantities are not typically large. So in equilibrium, the market participants understand that the actual final demand, which is this one here, it depends on the rationing rule as well, not only on the actual realized demand. And they understand how the supply, what is the supply as well, and they form expectations about the price, and then they make the investments and before this market clearing takes place. So this much I want to show, and then I show that because we have investments on the consumer side, and the consumers are effectively drawing costs of selecting technologies. Some of them will select into price-sensitive technologies. Some of them will select into sticky technologies because they are getting a high cost draw. And in the end, the final demand looks something like this: that you have a sticky part of the demand, and you have a non-sticky part that is responding to the prices. And in our setting, we think that you observe this whole demand schedule. That is reasonable because in the power exchange you observe the whole schedule, and if you have an idea of the expected price, which you can get from the contract prices, these two things allow you to identify the sticky and the non-sticky parts of the demand. So this is very important for our mechanisms, that you can identify these two parts from the aggregate observation. But I have to leave the details to the paper. And once you've done that, you can compute the surpluses for the sticky and the non-sticky parts of the demand if you start controlling the price. So we don't make assumptions about utility, but you derive the utility from the observed demand, as is usual in economics. Or sometimes we start with utility, but here we start with the observed. 3 minutes. Okay. So the price. If I show you the. No, you're counting not right, Andreas. Okay, so I'm fighting for my presentation. So here you can think about simple presentation, how it works. So you have a supply curve. You can think about where the supply curve is there, and then if the supply shifts up because of this Russia crisis, for example, then you have to think if you allow the price to grow to go all the way up to this area, all the way up to this level, which is indicated by X here, or if you want to cap the price, for example here, which is the PX star. And you want to cap the price, you want to set the price cap in a level that effectively sets the price equal to the average utility of consumption. And you calculate this utility from this information about the flexible and inflexible demands. And then what you do is that you always implement the rationing if the actual market price tends to increase this level that you calculated. And how you do it, as that effectively by rationing in a pro rata basis, you shift the demand to the left until the supply meets the rationed demand at that target price. So this is how you shift the demand to the left. You do that always when the actual market price tends to increase, go above the target price. So what we do is that we quantify this using data from the Nordic electricity market. We have like 56 million bits, and we have a software that is reproducing the market outcomes from these bits. And the bits look like this. For example, on the left, you have a sort of normal year before the crisis. You see that the demand there's quite a bit of demand variation, which is shaded area. Supply looks pretty stable. You get an idea of the distribution by the shuttered area. And then when you had the crisis, you see that the supply was suddenly shifted, like in my graph earlier, because of the higher input prices. And yes, that's pretty much that. And then what we do is that we can do numerically this estimation of the actual sort of target price cap, but we do the estimation with a semi-log demand function, because it gives you a better feeling of how the price cap is calculated, and this semi-log function fits the actual demand super well. So we estimate that demand for each hour actually. So we get the demand parameters hour by hour, and then based on those demand parameters, we provide a algorithm how to compute the actual price cap that is basically achieving this, that you get the average utility equal to the price. And then we implement that, computing the new equilibrium, computing the price cap for hour by hour. And here you see during the crisis year and before, the price cap is hovering way above the market price, so it's not binding. But this is the idea, that it should be there all the time, because then you are kind of capping the market expectations, how high the prices can go. And had this instrument been in place during the crisis time, we would not have these problems in Europe where the firms are not able to survive the margin calls and so forth, because these major energy companies had to ask funds from the state to survive. So, and it binds only in a few hours during the crisis, because the actual crisis was not so bad in the end. It binds only in 68 hours. It's mostly about shifting surplus from producers to consumers. The consumer, the total welfare is not so big. But we do a stress test where we replace the relatively mild winter with the cold winter, and then we get huge surplus shifts, like billions in euros in a few hours of that year, that counterfactual year. So I need to perhaps wrap up. But here's the idea why you can actually, with very small rationed quantities, you can get a big price stabilization impact. Because typically the supply and demand are close to vertical in these situations where the market is very tight. And now if you ration by shifting the demand little to the left, you get a big drop in the price. And this is, for example, here the market clearing price is more than 400, and now the rationing price is 450. And you get that by rationing the total demand by 0.5% or so. So DSOs can actually do that without going into rationing individual customers. So this would have been quite a bit of sort of benefit to everybody during the crisis. So let me just leave you with the literature that remember that the results that we have, they hold in uniform price settings. There is a literature telling that how you should implement rationing and set prices when you can discriminate customers. So if you have sticky technology, then you are facing a different price and a rationing protocol than those individuals who have non-sticky demands. But we are not doing that in practice, but everybody is treated the same in the uniform price setting. Okay, very good. I'll leave it to you. Perhaps 2 minutes, I would say.
So thanks a lot, Matti. Because of your strict time management, we have time for questions. 3 minutes. Aha. Pedro.
Thank you. Really interesting. But I would like to question. I would like to question your. You start by saying that price control is efficient. I understand what you're proposing, and they're an energy-only market. But of course, there's another alternative, which is to have, for example, a reliability option, which is a kind of price cap that also takes into account the supply side. So, because the problem with the price control and rationing is the remuneration of supply. So I'm wondering to what extent your results hold when you're dealing with this type of long-term instrument like a reliability option, which is also acting as a price cap, but is also distributing the load between supply and demand. So I don't know if you are familiar with this type of capacity markets reliability options, but
That's a very somehow I know the concept, but we kind of we didn't remember it while writing this paper. So that would be a good a homework for us to check what is precise connection to this reliability option. I think it's a really good point. Yeah. Thank you.
Okay.
Thanks for an interesting paper. I think it's the first time I've seen an economist arguing electricity for price controls. So I'm not sure I understood completely, but surely if you have price controls, demand isn't going to be rationed. You're going to have higher demand, and in a situation like we want customers to be faced with prices so that they reduce their demand. Just as a general rule. So maybe I misunderstood.
Yeah, you are absolutely right that if you could discriminate, you could get closer to what you are. But if you have to kind of buy, it's kind of institutional constraint that everybody's facing the same wholesale price. And in our setting, it's also we are thinking that it trickles down to a uniform price to the consumers as well. So so that's in our setting, it's just to get the efficient investments. That's what you need to have. That you need to put the control in place, because otherwise consumers would. When I think about it, it would mean that if you take the price control completely away, it would mean that the consumers would effectively overinvest in this sensitivity. And the producers would be holding. Well, it depends a little bit how what you assume about the production side costs, because it could be that all the extra investments are done by firms. They are holding most of the time idle capacity, waiting for these extreme events. And if there's only like a uniform price without any other mechanism, then they are over-investing. So, but I think your thinking comes more from this world where you can discriminate consumers, and you face a different treatment depending on if you are like if you remember the papers by Josko and Tirol, in their paper you observe who is price responsive and who is not, and then you design a different treatment for them. So, this is taking care of the incentives at the investment margin. That's better than what we have here. We are kind of respecting the institutional constraint that you cannot discriminate. Yeah.
Okay, excellent. So thanks again, Matti, for the talk, and then we move on. To JP Montero from Cook in Chile.
So they get this going here.
Yeah. Frequent visitors of Atosha, they are now already familiar with low emission zones because Juan Pablo has already educated us in some very nice papers. So curious to hear.
Let's see what happens now.
Curious to see what happens now. Floor is yours.
Yes, well, thank you very much, Andreas, Massimo, and Javier for this, not only this conference, but all the other conferences. This is really a great pleasure to be here. And let me tell you a little bit about this. There's no paper. This is work in progress, very much work in progress. I'm going to show you just what we have so far. It's joined with Nano Barahona, Natalia Fabra, who was a keynote speaker in the last conference, and Imelda. And this is about what is a transition technology. I mean, we understand that transition technology is a technology that you want to support during the transition toward, a zero carbon economy. And so this is what we're exploring here. And we're giving a slightly different definition of what you typically have in mind for a transition technology. I can tell you right away what it is. It depends also on the policy context. It's not just about the intrinsic characteristic of a technology and its price, but also in the policy context. Something can be a transition technology, for example, if you have to use second best instruments, but it would not be if you can use first best instruments. And this is exactly what we want to show you here. And eventually we want to test this using information from this second best policy implemented in Madrid, which is called Madrid Central. It's a low emission zone. So that's the application, but I think the question is is broader than that. It's just how we define a transition technology. Here you have, this is the global president of Hyundai, you know, a month ago, talking to the Financial Times about, you know, electric vehicles and hybrids. And he said, well, perhaps hybrids are going to be around for a longer time than we thought, for different reasons, you know. And so that tells you that maybe hybrids is a transition technology we should support. And so these are the questions that we're trying to answer in this paper, applied, you know, in particular to the transport sector. And are hybrids a transition technology according to our definition or not? And we know that they are not as expensive as electric vehicles, but at the same time, they're not as clean. So it's not obvious that you want to support these hybrids, and at least for how long you want to support these hybrid vehicles. And so, but what we say in this paper is that there's a missing component in the definition of a transition technology, which is the policy context. And I repeat here what I just said before, that there may be some technologies that are not part of the first best. So if you have access to Pigouvian, for example, taxation or Pigouvian subsidies, we know that they're not the same, you know, according to Robert's presentation. But for the moment, you may not want to have them. But if you don't have access to these, you know, first best instruments, perhaps you want to have them. So this is a question that we are trying to answer in this paper. And what is a second best instrument in this particular context is a low emission zone. You know, it's that you put a restrictions, you know, you don't allow some cars to enter into the city center, but you exempt other cars. In this particular case, in Madrid Central, you know, hybrids and electric vehicles are exempt from the restrictions. And so here you have a picture. This was introduced in May 2018, fully enforced in November 2018. And as I said before, you know, gasoline cars, they cannot enter, you know, the city center in Madrid, and hybrids and EVs are exempt from that restriction. And so what I'm going to show you here is the first two part of what is supposed to be a paper eventually. It's some reduced form empirical analysis, and showing that the Madrid Central mostly, you know, affect the adoption of hybrids. You know, because of that, you will see a greater adoption of hybrids, but not of electric vehicles. And then you start thinking, maybe it wasn't a good idea to have this hybrids exempt. If you really, in the end, what you really want to push for is more electric vehicles. And then I'm going to show you a very simple model to basically to give a little bit more structure to this definition. What do we mean by a transition technology and the policy context? This is work in progress. You know, the structural estimation, we already tried to get data, and we have something now, and then counterfactual analysis, but I'm not going to talk about that here. So here you have some pictures showing that actually, after the introduction of the Madrid Central in May 2018, we see a greater adoption of both. You know, I mean, the black dots are Madrid, the green triangles are the rest of Spain. We see, you know, an increase in the adoption of these green vehicles, both hybrids to the left and electric vehicles to the right, in Madrid as a response to the policy. Now, when you start, you know, digging, you know, deeper into, okay, you know, behind those numbers, using this synthetic control approach. I'm not an expert, but I know there are many people here that also shown some of this approach in all the papers. We find that that for hybrids, effectively, you know, the policy had an impact. We had an increase, you know, in the adoption of hybrid because of the policy, but not so much for the electric vehicles, you know. And then when we include this additional test, some placebo tests, basically, you know, assuming that there was some treatment in some provinces in Spain, you know, randomly picked, we see that for hybrids, you know, the results remain, which is the picture on the left, but for the electric vehicles, you know, the effects pretty much vanish. So, and you know, to conclude, I mean, if you want to conclude from here, is that this policy mainly affect, you know, we increase the adoption of hybrids, but not of electric vehicles. Is that a good news? Is that bad news? Is something that you had to? Well, that's part of the question that we want to eventually answer. And in this paper, but for that, let me give you a little bit of a theory context, the way we were planning to answer that question in the
structural estimation and also in the counterfactual analysis. So this is, I think, the simplest model you can think of to basically understand this definition that we want to advance, that the transition technology also depends on the policy context. So think there are 3 vehicles in the market: electric, clean, hybrid, and gasoline. And they are, equally located in a Salop circle, and drivers are uniformly distributed, along the perimeter of the circle. And this is important. Here's your utility. I don't know if you can see this. Well, I mean, there's a utility of a driver, buying vehicle I, that's the valuation, V, and then the price, and then the transportation cost. What is very important, I think is the key of this paper, is to understand how different policy instruments affect utility. Taxes affect the price. Prices are going to be higher. And it's going to affect, consumers on the margin. You were thinking about buying an electric vehicle, maybe a gasoline, I don't know, and then you move around. So you affect the marginal consumers. And low emission zone also affect purchasing decisions, but differently, affecting V, the valuation of the vehicle. So you reduce that valuation, not only for the marginal consumers, but also for the inframarginal consumers. So it's a very inefficient instrument in that sense. I don't know if that's very inefficient, but it's what we have. So these 2 instruments, they act very differently. One on the margin, which is efficient, and the other one affecting the margin, but affecting also, the welfare of the inframarginal consumers that are very far from the other option. And that is inefficient. So that's why we say, taxes are efficient instrument, efficient rationing instrument, and these low emission zones, these restrictions are inefficient rationing instruments. And the other assumptions is the market is fully covered, but that's what is important for you to understand. Of course, electric vehicles are emissions free, hybrids are in between, and gasoline vehicles emit some pollution, E. And the whole, the rest of the analysis, depends on these 2 parameters. E, how polluting are the gasoline vehicles, and alpha, how polluting are hybrid relative to these gasoline cars. The rest of the analysis, goes around these two parameters. Well, the demand is a standard demand, in this Salop model. If everything is equal, you have, the market will be shared equally between these 3 vehicles. And here you have welfare expression. And for the rest of the presentation, and we're going to assume perfect competition or a constant markup. That the seller of these different type of vehicles, they compete either perfectly or we consider a constant markup. It will work either equally well. And also for the analysis, that follows, we're going to assume that we are in a symmetric setting, simply for presentation purposes. All right? So as I said before, these 2 instruments, Pigouvian taxes, first of the instruments, and this low emission zone policies, they act very differently. One by changing the price, consumers face, and the other one by affecting, this V, this valuation for, driving either this vehicle or this other vehicle. And that S there is the size of the less of the emission low emission zone. The bigger the low emission zone, the more value you destroy. And it's an important policy design parameter. I mean, because another important, I think, aspect that you need to understand from these policies is that they are all or nothing. Either you want to have a low emission zone or you want to have as large as possible. Why is that? Because the welfare functions are convex in this size. So either you don't want to have one or you want to go all the way. And sometimes for political reasons, perhaps you cannot, have a larger low emission zone. But this is something that we're planning to study, when we have the estimations and all that. Is this the optimal size in Madrid? Should be bigger? I was talking to Nicolas during lunch, and he's doing work on different low emission zones in Europe, and he told me, yeah, there's some low emission zones that are much bigger, than smaller. That's also, a policy design aspect that you need to pay attention to. In principle, you can use two low emission zones, different sizes for gasoline and for hybrid, and you can replicate the work of 2 taxes. That's true, and you can get the same market shares. That's no problem. But welfare will be very, very different. So some people say, well, these instruments are equivalent because no. You can replicate the same market shares, but not the same welfare. The low emission zone gives you a lot less welfare. Why? Because you destroy, again, I'm sorry to repeat this, because you're destroying welfare from the inframarginal consumers that they're not ready to switch, because they're far from the other options. And it's efficient that those guys don't switch sometimes. And so how much time I have left? 4 minutes. Perfect. So here is, if you're using Pigouvian taxes, if things are very clean, you want all the 3 cars being sold in equilibrium. If things are not so clean, you may only have, in this, Salop setting, it's nice because it's very discrete. Either you have all the 3 cars, or there are situations in which you have only one electric, or electric and hybrid. And that is going to depend on the emission levels. And for the less, again, this, remember, one important parameter, design parameter, is the size of the less. And of course, whether you want to have both gasoline and hybrid, for example, restricted, or only gasoline cars, is going to depend on these 2 parameters, E, the emission level of the gasoline cars, and alpha, the relative, emissions of hybrid respect to gasoline cars. So I'm sorry for this picture, but I think I want you to pay attention to the area, there where it says H equal transition technology. This is when a hybrid is a transition technology, according to our definition. What is this? It is a combination of emissions, and alpha is on the horizontal axis, and E, the emissions of a gasoline car, is on the vertical, are not so dirty, not so clean, so that if you could use Pigouvian taxation, they would be no part of the first best. But if you cannot use Pigouvian taxation and you can use this less, they will be part of the less. They would be exempt from the less. That makes hybrid a transitional technology. And that is the area that you see here in the middle, in which, this is the way we see, if we are over here, for example, very clean gasoline cars, all cars should be part of the first best and also of the low emission zone. But it's in that sense that we understand, hybrid as a transition technology. They're not part of the first best, but they are part of the second best. And now, talking about, this is for any less, and then you talk about the optimal less design. I'm about to conclude. And as I said before, because you have this, let me jump to this picture, I think it's better. Here you have how welfare changes, with the size of the less. S bar is the size of the less, the maximum size that you can have, and then you have different welfare functions depending on this size as a function of the emissions. When emissions are very low, below that's E lower bar, well, you don't want to have any less whatsoever. Cars are sufficiently clean. When they are not so clean and you are equal to, for example, this E lower bar, either you have a less of this size or nothing. And that is because these welfare factions are convex. So what is the important message? If the less cannot be large enough, it's better to have nothing. And that is, for example, when you are in the second, the second curve there. If you cannot go all the way here with the size of the less, it's better to stay here and do nothing. These are like bang sort of solutions. Either nothing or you go all the way. And because of the convexity, because the way you are destroying, the welfare of these inframarginal consumers. And final remarks. Next steps, I can't tell you anything yet. So on the empirical evidence, I think we found evidence that this policy did affect adoption of green vehicles, but mostly hybrids. I don't know if hybrids qualify as green. Not of EV. Is this good news? Is this bad news? We don't know. I mean, some people say, well, this is bad news because basically people would have adopted more electric vehicles instead of these hybrids if they were not exempted. But they were exempted, and then this is the ones you want to understand. This is a policy design question. You want to include hybrids or not, and the size of the less. These are the things that we're planning to do, in the future when we have the structural estimation and then start running this counterfactual exercises. And also there's another question, how you can complement, because I know it's very hard. I mean, Robert mentioned this, to go to Pigouvian levels with these taxes, but maybe you have some. So what happens when you start complementing, the low emission zone with other policies? Taxes at a lower level, and then how they interact, and what things you would change. That also we're planning to study in the future as this project progresses, but that's going to take some time. Thank you, Andreas.
So, now we can entertain some questions and hear Madrid calling.
Sorry again. Me again, sorry. I find this really interesting, and I'm looking forward to reading the paper, but I would like to suggest adding a new layer to your analysis, because the problem that we are facing in many LES is that they are designed to reduce atmospheric pollution, but as a result they are increasing CO2 emissions, because typically the way you reduce atmospheric emissions in a hybrid car is by getting a lower efficiency. So I think it would be really interesting to add that layer into your analysis and to show how some transition technologies might be good for this goal, but might... Right.
I also have a small comment. We've looked at hybrids as well, and the question of whether a transition vehicle, not a transition vehicle, and the problem is the great unknown is what proportion of time they drive using the fossil fuel and what proportion they drive on the battery. So it's also a comment, you could put something in your model with like a little factor where you make different assumptions on, if they're driving gasoline all the time, then they're worse than a normal vehicle because they're heavier. But
you're right. I mean,
if they're
here
driving
we're assuming
electric,
that you are driving either one, or the other.
Yeah, so you could be doing
one
like
individual, one
half,
car.
you could be doing 1 to 3. You could play around with those assumptions.
Yeah. Yes.
So these are suggestions.
Yes, very good.
Very good.
Excellent.
More suggestions. Give some homework to Juan Pablo. No? Okay, so thanks again. Take this with you.
Thank you very much. Yes.
In the next session, we will discuss how we are going to learn what you have done, because usually we are better informed about your less work, but we'll find another forum to find out. Okay, hopefully. Okay, so perfect. So now we move to next speaker, Sebastian Houde. 15 minutes, he will do fine, and he's at Geneva?
No, Lausanne.
In Lausanne, okay. So in Lausanne. Okay, and then fireside chat. That's for tonight.
That is good. Yeah. Excellent. And Control L. Yeah, for you. Just want to see how you.
Double arrows in the upper right corner.
Double arrows in the upper right corner. Yes, first thing.
Good.
First time using PDF for me. I'm getting there. With precious co-authors. This is a big research program that I'm just starting. We have been putting data for a couple of a year plus. So I'm really excited to share the first output. The paper is not there yet, but we are getting there. Okay, so I created the slides yesterday. I had a bit of a moment of eco-anxiety. Not much good news yesterday at the end of the day, huh? We like gaps, a bunch of puzzles. This is good for us, endless source of papers. But the solutions are kind of quite working. So trying to sell that, this is what Matthew said earlier. I think we need to start thinking really hard and really fast about the adaptation. And this is happening. An adaptation at the end, this is we'll need to move people and move economic activities. So there are a bunch of questions that are really important that we need to address. And here another gap that I just created. So this is France. Actually, this is a map of France. And if you look carefully, this is the inflow of people post-COVID. And the gap is the following. I call it the migration gap. People are not quite moving where we would like people to move if we think about adaptation. A lot of people are going where Professor Hanemann will go for his holidays, Cap Ferret here. Very dangerous in terms of sea level rise. So there are beautiful houses of your friends. Might not be there in a couple of decades. High risk of forest fire. The south, this is the worst place for heat stress and so on. But this is post-COVID, we're tired, let's move, and let's put all our savings in the probably wrong place. Okay, so what policies we should put in place to move people to the right place in the long term? So the three pillars of environmental policies, information, incentives, and regulation will be really important. We don't know much. There's a nice paper about information by Rob here. But we are just starting to study those different policy levers. So what we are doing here, and before going there, it's where we are going. I will argue that we kind of need a better understanding of the baseline. Actually, what people are doing now in response to Mother Nature. Okay, so we'll try to do a deep dive to the response of people to extreme climatic events, and try to understand if the question is there any movement? Okay, it seems that post-COVID, people were not having that in mind. So we'll try to dive and try to understand if there is any behavioral response to this. And then we'll look into the mechanisms, if there is really what I call a migration gap, why there is a non-response or some response. And we'll look, layer by layer, we'll try to understand if there is a response. Okay, punchline, yes, we see some. What are the market outcomes? So we'll try to understand the whole sequence of actions, from intention to actual moves to how the market react to those type of shocks. And I would argue that once we have a good understanding of this, okay, now we can start thinking about the policies that take that into account. So that's the research program, I would say. And so today we'll do a quick case study. Okay, we'll look at one event, so we'll try to be really precise on what we are trying to do to achieve. We'll go deep in this case study to look at different margins, and this is our contribution. Okay, we'll think about extreme climatic events as maybe an information shocks, not so much as something that impact you physically, but that is really salient, and we'll see how things, how people adapt to this on different margins, possible mechanisms, and market outcomes. Okay, for the sake of time, contribution, this is for you to judge. So let's start with this event. Okay, we decided to use the 2022 forest fire in the region that is on the west coast, just up north, Forêt de Landes. This is a beautiful place that is a UNESCO heritage site, Dunes du Pilat, and those forests were actually planted a couple of hundreds years ago. And this is really an example of humans playing with nature. Okay, it was a marsh and swamp there, really. And they planted the trees that could absorb the most water that you could think of. So this is really a place where we created a matchbox, literally. And once in a while, this place is burning. So in 1949, there was a gigantic fire. 82 people were killed. And then 2 years ago, there was a fire of about the same size. Nobody was killed, but it was the largest, I believe, since 1949 that burned a lot of the area. Okay, so this is our starting point. This is a very localized shock. It was, still large in share. So about, from the areas that were impacted, about 3% of the whole area were burned. But it was also a very salient shock. Okay, so that is a media index of forest fire coverage in the news, French newspapers. So you see across the years, you see the forest fire seasons, the summers, but the one in 2022 was really exceptional in terms of salience, of media coverage. Okay, so the information shock was really important. That is national news. To come, will show you the geographic distribution of the media coverage. So we have local and national news. So to distinguish a bit how the coverage was different. We have also information on all type of extreme climatic events. I can tell you that if you compare all type of events that occur in France during that period, it was also one of the most covered event in this period. Okay, about 4% of all newspaper articles related to extreme climatic events are related to, during that period, are related to that fire. Okay, so very salient, very big shock. And so this is what we will study. Okay, so this is the work we have done so far. We have assembled, starting from media coverage, we have intention to move. So we are working with the main online platform in France. So we have people searching for properties, rental market ownership. France is a bit special. There is one platform that is dominating this market. So we have the data from that platform. Then we have change of address from La Poste, so the main, main mailing mail company. Okay, so La Poste is nice data. This is like census data, but a bit more precise. We know the exact timing of people changing addresses. We know also if this is a firm or a household, and we know also if this is a temporary or a permanent change of address. So we'll play with this a bit. We have, of course, the micro-level census data, the universe of housing transaction. We brought the Airbnb data to look at the short-term rental, and we have also the risk. Okay, so all that will allow us to look at different margins and look at behaviors, migration, and also, market outcomes. Just a word on this data, how it works. So we'll be able to create flow at the individual level, but let's be careful here. We don't exactly observe an individual. We observe an IP address. Okay, so this is a cookie that registers your machine, your device on the platform. We know the municipality, the location of the IP address, but we know the exact location of every search because they are searching for a given property. Okay, so we have an exact location in terms of destination. In terms of origin, this is a bit strange. What we have, okay, this is an IP address. If you go around your laptop, things will move a bit, okay, because of that. So what we do to try to pin down people and location origin of the search, we do a data cut, okay, so we restrict the type of searches that we are looking at. So we only look at search between 7 p.m. and 8 a.m., which for most people, this is non-working hours. And we exclude search from mobile app. Okay, so this is the main data cut we do to try to pin down where people are living. Okay. La Poste, very simple. You change your address, you send a request, so we know where you were exactly where you were living and where you are going. So we have flows for actual moving decision. Okay, we don't have the whole universe of people moving. With the census data, we can see that, but we have a good coverage, about 70% of the people moving. Okay. Again, why this is better than the census data? We have the exact date, so we'll see this is an exercise that we are trying to be really precise about the timing of when people move. So that is more precise data than census data. Okay, so just a word on data, and I'm done. And I show you nice pictures, and we'll have fun. We aggregate, okay, the flow at the origin or destination level. So all the work, so you will see this is one regression, always the same. The log of an outcome variable at the municipality month level. Because this is flows, sometimes this is aggregated at the origin. So the outgoers, people trying to move out of the impacted areas, and the incomers, people trying to move in or not moving in the impacted areas. And for market outcomes, those are not flows, so this is really straightforward how we think about the data. This is just aggregated at the municipality and year level. Okay? One shock regions very clearly defined. So this is the perfect setting to do a synthetic difference in difference. This is what we do. Okay, so very simple, municipality level fixed effect, month fixed effect, and we have fire in the impacted region post period. So we go with this. Okay. Sorry. Ta-da! Results. This is not showing very nicely. Sorry, I could do a better job with my R skills. This is where I am in life. PDF, R, to do better. Okay, I'm working on this. But what you cannot see, but I'm telling you this is there, this is at the shock of the fire. This is intention. So people searching to move out, we see a big increase of search behavior. So much more clicks of people living in the impacted regions, searching more on the platform. Okay, so there are intentions, something is happening. And we see, this is not, I see, and I know, incoming, we see also an increase. Okay, so people thinking, coming in, we see more search in the impacted regions. What about actual moves? We see people moving out, so we see a movement, and same thing, less people moving in. So let me show you now things that you can all see. This is the regression coefficient. This is mobility intention, the search behavior, outgoing, incoming. So we see more search behavior, marginally statistically significant at my p-value here. But we see actual moves also, people moving out and people not moving in. Okay, so this is for us the proof of concept that this years of collecting data, and okay, we have a shocks that okay, people in France respond to extreme climatic events and something going on. So now let's dive and try to understand a couple of margins, mechanism, and also market outcomes. So let's look at the search behavior and see what's going on. So who is trying to move out, who is trying to not moving, or who is curious about moving in or not? We see that on the ownership market, okay, we see much more outgoing behavior. So that is the almost 5%. But the rental market, not much behavior. Okay, so this is really on the ownership market in the impacted regions that people are thinking, searching to move out. Incoming, we see a bit of, okay, on the ownership market. And then we see a big effect of renters not living in these regions, but looking in the impacted regions, we see much more search. Okay, so a bit of a puzzle here. But this is where we see the biggest increase in search behavior. People outside the impacted region looking inside the impacted region. Okay, so let's see what's going on there. So let me look at the number of a unique searcher trying to come in. Okay, unique searcher, watch out, this is IP addresses. But is it extensive, intensive margin? Is it the same people always looking at the properties and searching more, or new renters, new potential renters? And what we see is that most of the action are the rental market. So this is new IP addresses, new visitors looking more in the rental market in the impacted regions. So, okay, that's a bit the puzzle here, or the information effect that I'm trying to get at. So, okay, there was those big fires, and some people started to play more with the search platform and looking more into the market. So that is on the, coming in. Okay, what about people getting out? That much less of a puzzle. Okay, this is as expected. We see ownership, the ownership market, people searching more, and this is also where we see most of the behavior. Okay, what about other outcomes, market outcomes? Well, we see people moving out. So we should see some action on the housing market. Indeed, we see the number of transactions increasing by about 7%. That is consistent with our migration behavior. So this is about the 6% we found. So this is on the same order. What about firms? We don't see any movement for the moment. So we are looking, this is short-term response, 1 year after approximately. So we see zero impact for the moment with firms. So people move first. We'll see if jobs or firms will follow, but for the moment, no action on the firm side. Okay. And I will just conclude on this. What about, okay, so, this rental stuff, incoming people seems a bit crazy, right? So can we, French people are a bit pervert. This region is burning and you start looking at the housing market, what's going on? So let's go and think about the Airbnb. What happened? Well, we see that the number of listing in the impacted region increased slightly. This is p-value 0.10. I will not push that too far. I can imagine a bit the dynamic is happening there. Okay, you have your second home there, decided not to go for the summer, and you put it on Airbnb. I could rationalize this. But we see that reservation, whether you measure in the, irrespective of the length of the stay, number of days, going up, more revenue, but didn't increase the price per listing. So more or less, we saw more people going, visiting that region during that period. Okay. So trying to triangulate what is happening here, but it seems, seems the information channel is well into play. Okay, there is something going on. So the attention to the region made people thinking a bit more about that region. They visited a bit more even. For the rest, we see kind of a, non-puzzle, less puzzling things. We see movement, response, we see intention, but also actual moves out of the region. And something that I didn't highlight too much, but the movement is from the homeowners, not the rental market. So it seems that the ones that are more locked in are more the renters than the homeowners, at least in the short term. And that also has the implication for the next step when we think about policy. Okay, good. Thank you.
Thanks a lot, Sebastian. I'll start here, Michael.
So when I studied oil spills, in Los Angeles, there was a spill, the beach was closed. You had a huge number of people coming to the beach, not going on the beach, but standing, so they're called looky-loos. But maybe in your case, it's something different. It's not looking. You read all these stories, a beautiful part of France had a fire, and someone says, wow, that sounds like a really nice place. So it sort of makes it more salient. And that's the increase in inquiries.
Yeah. That's true. Never heard about it, before. It looks nice.
Thank you.
Pedro.
I had another question, but as a follow-up to what Michael was saying, in Spain in the Canary Islands, we had a volcano erupting, you remember that? And that created an increase in visitors just to watch that natural event taking place. And so there was an increase in short-term rentals associated to tourists that wanted to visit the area. So maybe there is also some element of that related. But my question, I had two suggestions again. You probably have already thought about this, but when you were explaining your data, I was kind of thinking, what about housing prices as proxies for these changes, these movements?
Yes, of course. We have all that data. This is just, me being slow with R.
Yeah.
The challenge with housing prices, this is not a big event. So we see volume, but it's a bit more spotty. We need to aggregate at the trimester level, so we are just dealing with this. But
and
next
the second
version
question,
we'll have this.
The second question is about your final comment on renters versus owners. To what extent that could be linked to income? To what extent, for example, low-income people may have more friction to move because they have more difficulties in finding another job, or high-income people would be more flexible in moving?
Yeah, thank you. So the labor market, this is something we'll dive in to understand a bit more. That's why I know well those data, and they are not yet in my office, but we'll get there. So we'll look at the labor market impact. The treated municipalities that we have, 300 at the end. So we cannot do too much heterogeneous treatment effect there. We are trying to be a discipline how we do this. But we'll look at a bit of the labor market, but this is there. Yeah, thank you.
I just have a question related to the estimator. So if you tried also maybe as a robustness check, also estimating a gravity model for the effective migration, bilateral migration. Yeah, so
we are not, for the moment, we are going for volume. So a lot of outcomes variable, some same estimators. So this is easy to track. But when we'll dive in the flows, we're excited to see also the distance, those margins, internal flows, and so on. So yeah, we have a lot of work to do to understand the response. But the point was, okay, is there any response first? And I'm saying, okay, something going on. So you will hear me talking about this for a couple of years, if I knowing myself.
Yeah, doing research out of Lausanne, excellent.
Okay.
Okay, thanks a lot, Sebastian. Okay, so we move on with Hermann Vollebergh from Tilburg University. We are going back to the clean technology in the car market, I guess. And that looks good.
Old-fashioned PowerPoint.
It's good. Hermann.
But it works.
50 minutes. Floor is yours.
Yeah, you give warnings, right?
Yeah.
In time.
Yeah, but you have to look at me from time to time.
Good. Okay, thanks. We go back to innovation and policy-induced innovation, actually. So it's a bit of a follow-up, not of the low emission zones, but a different kind of treat in this case. It's joint work with my PhD, Rick Rozendaal, who is about to finish his PhD very soon. Let's see how that works here. Why it doesn't move? Let's see here. Sorry. Oh, it was out. Yeah. Okay. Yeah. Okay. And there was also some need for good news. Now, here is some good news. If you look at the electric vehicle market overall in the world, you see a lot of action happening the last couple of years. Maybe it's a bit changing in 2024, but our focus is anyway back in time, because we want to explain where the knowledge comes from. The knowledge of this type of vehicles is not something which falls from heaven, but which really should be developed over time. And now we also see that the share of new cars in some countries is already extremely high. So the basic question is, where do these radical new models come from? And in this paper, we set up a patent database, because patents are still, I think, a very good indicator to have an idea of what new technologies look like and what is necessary to develop this kind of adoption technology in the end. So here you see basically in black the dirty technology, let's say the dirty technologies. No, sorry, I have to check, but carefully. So both of the dirty technologies and the green technologies had a very slow rise, but in the 90s, as most of the patents have been rising in the 90s for I think other reasons than it's I think a strategic kind of reason, because you see it everywhere. But for the car technologies, and specifically, you see green and gray lines, and then it's very clear that the green technology is overtaking the dirty technology patents at some time, and even is higher and still is higher in the periods where we look. So our sample is between 2000 and 2016 at the time that we could collect these data, because there's always a time lag in patent data. It takes about 3 years before you really have a good picture of the patents developed in a given year. So yeah, for us it was a question, why is this change so strong? Because it's remarkable. The search of clean patents is there, but it took over only in 2010. But is that because of prices? Because in the literature, as you perhaps know, in the directed technology change literature, it's really prices which bring forward this kind of change. And indeed, in the paper of Acemoglu about the car market, of Agion about the car market, we see indeed that these fuel prices really explain this kind of changes. But in our case, it's more a general finding. There's also other literature which shows that prices are really driving this kind of changes. Market prices usually as a proxy also of regulation. So then you take tax-inclusive prices, and then another argument that you could also have a change like this by using taxes. That's, I think, quite a standard in the empirical literature. In our paper, our focus is much more and very dedicated to the market of IDs. So we really separate out the adoption of this new type of technologies and the incentives which really explain this kind of changes in the market. We really only focus on the market of IDs itself. And another thing is that we really look carefully in the characterization of the incentives. So the incentives and the design of the incentives is really fueling our analysis. So also to bring forward the main result, we find in our paper not that prices are driving this change, but standards. So the standards that have been imposed in the US and in the EU around 2015 are driving this result. And I think that is really an interesting and quite new finding. Now, how do we do that? We do a detailed analysis of the attributes which together can be used to very carefully identify the impact of a specific instrument on the patents or the innovation. We develop a measure for regulatory stringency, which is also a new kind of measure, how you can carefully look at the standard and the attributes of a standard in terms of what is the signal in the end and how strong is that signal. This measure takes account of precisely that. And by using this measure in our estimations, we have a very robust kind of explanatory variable, which can be used across all kind of robustness checks. And in the end, we cannot get rid of it. So you can also explain it that way. So what is then basically the dynamics in this car market? So we normally also, we look a lot at the manufacturing firms and how they make their decisions. There's a very nice paper in the Quarterly Journal now about all these options. Now, Antonio is here as well. So there's mix shifting, there's trading off vehicle characteristics, and there's of course technology adoption. But this is all based on the known technology frontier. And then only if these kind of things do not work for the car manufacturing firms, there's the option to innovate. Because innovation is costly, so you do this only if you believe that it's necessary to comply with the regulation or to serve your consumer demand. In the car market for IDs, we're not talking about the car manufacturing firms alone. And that's also a very big thing. So the incentives for the innovating firms in the car market are not the same as the car manufacturers. So if you look closely at who are the patenting firms, they are sometimes connected. It depends on the region. In Japan, it's different than in Germany, for instance. But it's very important to realize that R&D firms have a different incentive relative to the car manufacturing firms. I've discovered that earlier in another paper on patenting, where you also see the same kind of thing, that the innovating firms, they also like standards, actually. They like stronger regulation because then they can sell their stuff. So that's one of the motivations, I think, which is in the background working and explaining our results. So how do, let's say, innovators respond in the market for IDs to incentives? That's basically the setup of our work, right? So the decisions are based on current prices, but also, and importantly more, I think, about price expectations. Also about regulatory expectations, and announcements on these standards you may expect that if you are a firm and you really expect a stringent standard over time, that you should respond to that strongly. Okay, then the last step is the instrument and the attributes of the instrument, which are also important to take account of. So these are the three main mechanisms that drive the decisions. Of course, I don't have enough time, so I go through some of them. This is the fuel tax, one of the incentives which are usually taken into account and also in the Aguillon paper put forward as an important explanatory variable. You see it's only cross-sectional variation. There's not much time variation for the excise tax. It's good to keep that in mind. More important is the standard and how to deal with the standards. Now here's the EU as an example. So you see that around 2010, there was an announcement of a more stringent type of regulation. Before 2015, these were non-binding standards, as we call them, because they were voluntary. But after this period, there were announcements of quite strict standards which would also be imposed, and therefore we consider them as binding. We have a similar pattern in the US, and Japan is very different in the sense that Japan had in the beginning strict standards, but then switched to voluntary standards. And you will see that it makes a big difference for the outcome. Now, I have to keep this short. So here is the measure of stringency, how we developed it. We take through elements into that measure. That is a distance to target, a binding or not kind of thing. So it's a 0-1 thing, and the years until the enforcement. Because there's the announcement at a given date, and that's far ahead. It can be 6, 8 years. So, but now you already know that the stringency can be large if you look at the distance of your car fleet at this point in time relative to the standard which is binding or not binding for you as a firm. So we put this kind of measure in our estimations. Now, what is the kind of estimations? It's a sort of standard way to deal with this kind of thing. So it's a count data model with different type of possibilities to estimate. We do all the identification which is common in this kind of literature, also to prevent endogeneity, lagged variables, knowledge stocks, etc., etc. Knowledge spillovers are there, and of course the standard and the fuel tax, but separated from the price. That's also important. So we have really the price separated from the tax, from the standard. So all of them can be explanatory variables and also subsidies in that field. Now this is a key kind of outcome. I told you this kind of measurement of the standard is very robust across all kind of specifications which we tried. It is the explanatory variable for clean patenting in the period that we observe. The dirty firms are clearly, of the dirty patents are not significant. There's no clear reaction to that, but for the different variables. There's some effects if we pool the patents for clean and dirty in this way, then the fuel excise is also significant. Tax exclusive fuel price is never significant in all the specifications that we try, and then we have the sort of outcomes for the knowledge stock, but I don't have time to explain that more. So what is the outcome? But basically is that both standards and taxes in the let's say the pooled version do indeed explain this swift shift to clean patenting, but there's not an effect on the dirty technology. And there's also not an effect of the tax exclusive price, which I think is a very important outcome. If we disaggregate that to technology classes, back to electric, hydrogen, hybrid, grey, and purely dirty, then again you see that the standard stringency is important, in particular for electric cars, but also for hydrogen cars, and not so for hybrid cars. So in the period that we observe, there's even a negative effect that we observe here for the tax exclusive fuel price, and I think that is linked to the developments in the Japanese car markets at that time. So also here, just summarize, no effect of the tax exclusive price on clean innovation. It's even a negative effect on hybrids. The excise tax doesn't play a role anymore, but standards are still there, and they very clearly have an effect on the two kind of technologies that you really expect to be clean, and hybrids seem to behave in terms of the innovation a bit like the dirty technologies. I told you we did many robustness checks in the paper. This is not a paper, a work in progress. It's really finished and almost published. So everybody who is interested can look at all the details of these different kind of estimation strategies and robustness check. The stringency effect never leaves us, so it's important I think that's a real important outcome that we have. Still, you can And that's something we really deeply had to think about, is the endogeneity problem. And indeed, we are observing now more and more discussion about whether knowledge stocks and lagged variables are sufficient in this case to indeed control for endogeneity. So we put a lot of effort in showing, of looking very carefully in the time frame where we were looking at. And here it's never expected, also not by regulators, that electric cars would be the main innovative kind of thing at that time. So the likelihood that you could impose very strict standards based on the expectation among regulators that electric cars would make it anyway, that is very unlikely to have happened at that period. So that's why we think that endogeneity, even if you're not satisfied with the standard type of controls, also doesn't play a real role in our results. Here is the counterfactual analysis that helps to understand a little bit the outcome of our variables. Overall, you see clearly an effect in the whole period, and if you split them in the three regions, you see nicely that Japan, when it left the let's say the strict standards and imposed voluntary standards, they started to begin to lose in terms of innovation, whereas the EU and the US clearly benefited from the fact that they announced these kind of standards. So, our conclusion on identification, we think that we have a proper representation of instrument attributes, and that it's very important to have this type of very specific representation of the instrument attribute to do the right type of identification. Our stringency indicator performs very well in that respect, and on instruments we can conclude that excise taxes don't seem to have much of an effect. In a sense, I think that is related to your paper, that where the standards are in a sense a quantity indicator, and for engineers, that's exactly what they like. They like to have a very clear indicator of where to react on in terms of their innovation, and that's exactly what standards do. That's it.
Thanks a lot, Hanemann.
I mean, it seems that there's like a sort of a ratcheting effect, right, with the standards.
Sorry.
You start with the very high standards, and as firms innovate, then you start ratcheting down these standards. It's a classic, no commitment sort of regulation, in which as you see progress, boom, you ratchet down these standards. I mean, it's a nice picture that you have there.
You mean this one, or the?
Yeah, that one, exactly.
Yeah, it is. So I think it tells you the story.
Well, the question is whether firms are
line.
anticipating when you're innovating. You're anticipating also that is this is going to be ratcheted down later on, and so the incentives are already there. In 2005 for what is happening in 2015, because you anticipate that this is coming down anyway.
Yes, sure, but you also know that it's not enough, and that the trend is there. I agree. So there's some kind of expectation. But not for the second round in the EU. You see that the distance is really serious. And I've seen also already some new kind of results for the later period. And this may also explain why Volkswagen and all these kind of scandals came up, because the distance is very large. So there was a very tough standard announced, and it was also credible standard. So you really had to react, but maybe it was cheaper to cheat than to do the real investment, because as a car manufacturer you have many different kind of reasons to check the different options you have. Can I comply with the standard, yes or no? But that's really a different type of question, which we don't address. We only look at the innovators, that they know what's going on, they have expectations, they form expectations, and then they start doing additional research, and that's exactly what this picture shows. So it's really in advance. So the regulator announces in advance 5-6 years, and so that gives you time.
Thank you for the presentation. So car makers compete in international markets through international trade, and so different regions actually impose regulations or update regulations almost the same timing, during the 2000s, during the 2010s, and also fuel prices changed very drastically around like 2008, 2010. So just wondering, in your estimation strategy, how, you know, what kind of strategies did you take to identify or separate the effect of like regulations in different regions, effect of fuel prices?
Okay, yeah. So these are firm level data. So we identify the firms in a given location in the different regions, and that's basically the assessment we do.
So like for example, like the updates in EU regulations also affect Japanese.
Yeah, of course. Yeah. So there's a linkage between, let's say, the car sales of the sales of manufacturing firms, or in terms of where they are expected to sell their cars, and this kind of variable this share we use as a share to investigate how large and how important that market is relative to their home market. Yeah, that's part of the estimations. Yeah.
Okay, so thanks a lot again for the presentation and for the discussion, Hermann. And now the organizer of the program has planned very wisely the last topical presentation that we are going to hear is by a dream team of the Atosha workshops, which is José María Labeaga presenting from UNED in Madrid with Xabi Labandeira and Michael Hanemann. So very fitting last presentation. And floor is yours, 15 minutes.
Oh, thank you. Thank you for inviting me. But probably you ask what I'm presenting another price elasticity of energy, because there are hundreds and there are meta-analysis. But this morning the Robert impressive talk convinced me that the price elasticity is the key. It's the key for calculating his MBPF, and it's the key for everything. So sorry, but I'm presenting another price elasticity. Anyway, Michael and Xabi are here, so if you have any comment, any complaint, any suggestion, feel free to ask them anything that you like. So that's this paper, which is published early this year. It's discrete continuous models of residential energy demand with Michael, also Xavier, and Felipe. And I don't know whether we make a mistake in this paper, because I'll show you that. In this paper, in fact, what we like to study is whether the estimation of the price elasticity in the two alternative scenarios that we have to deal with corner solutions, the extreme corner solutions case of David McFadden and Hanemann, of the general corner solution of Wells, Woodland and other colleagues, works or not. Because remember that we are going to ask individuals for answering questions in surveys. But individuals are going to take decisions in both the extensive and intensive margins at different times. So it's not the same to change the heating system that to use electricity for watching TV every day. So that's the setup that we like to analyze. And the mistake that we made in the paper is that we write this in the last paragraph of the conclusions, which is our findings in this paper will be the subject of a separate paper intended as a complement to this paper. So this that I'm going to present is a draft, and we are working on this kind of things actually. So that's the main aim, try to improve the estimate of the price elasticity of energy demand in the Spanish residential sector by fuel type. And it's because we have the right data, because residential energy demand is to adjust the price elasticity is very important, because energy pricing matters greatly for energy and for climate policy, and because we have to have very good demand functions estimated with the best data at our disposal. So the idea is to decompose the two, like in the Davin, McFadden, and Hanemann papers, and this the data that will allow to do a different thing that is done in the literature. We identify the source of energy for heating, but we know also whether the household saves for changing the heating equipment, and we know whether the household really changes the heating equipment. So these two variables are going to allow us to form what we name the change group of those households in the market for having these two decisions linked. So we are going to contribute here with an extensive testing of several assumptions behind discrete choice models. Then we are going to separate the sample to link well the discrete choice model with the continuous part of the model, the conditional demand, and we are going to estimate price parameters in this context and to compare with other contributions. A preview of our results is that we find robust evidence in favor of models with sample separation, because the two decisions are taken at very different times. And in particular, for models estimated for what we name the change group, those in the market. And it's robust evidence in the different ways that inertia, which is the source that the household had in the past, affects the discrete choice, and also in the price effect in both the extensive and the intensive margin. There is another result, which is to compare with Davin-McFadden model that also gives an evidence that they put prices of complements or substitutes in the conditional demands, while the theoretical part of our model don't have these prices in the conditional demands in the second decision. So I'll do that. So let's go with models. It's very easy. We have two models. We have the indirect utility function for the choice of fuel type J, this indirect utility function for household I, and we have a vector of explanatory variables and random terms, the usual things, extreme value or multivariate normal distributions. So we adjust the discrete probability. So the individuals compare the indirect utility across the different alternatives and decide the alternative that is the maximum probability. Then we have the conditional demand function, which we approximate with that. It could be variables common to W and Z. And the thing is that we allow that these two unobservables in the indirect utility function B and in the conditional demand function mu are correlated. So this formulation abandons the notion that discrete and continuous choices arise only from maximization of the same parametric utility function, which is what Davin-McFadden has. So this is our model. And we link discrete and continuous choices via the deterministic component, the random component of the model, which we allow to be correlated, instead of what Davin-McFadden and Hanemann did, which is that they link through this deterministic component. So the reasons for this linkage I have mentioned previously, because these decisions are not taken at the same time. We don't think that, except if by chance the substitution of the heating system is because the heating system is broken, and then the change is immediate. If not, households are not taking hourly, daily, or weekly decisions on changing the heating system, while they are doing these decisions hourly, or daily, or weekly for the conditional use of electricity. So that's just an example of some problems with the general model at the linkage if we consider the Davin-McFadden situation. Let the note E, electricity usage for heating space and water, and Xg, gas usage for heating space and water. We include an outside good, and then we have this unconditional utility function. And we have household total use of electricity, which is the sum of the electricity for heating and other end uses. And then we have the unconditional demand for electricity for heating, for electricity for other end uses, and the total unconditional demand for electricity. And similarly, we can define the conditional demands. So, David McFadden, we presume, is our guess, that they're assuming that the optimization problem is to maximize this utility function subject to the usual budget constraints, prices of electricity, PI, prices of the outside goods, PN. David McFadden assumed that the total demand for electricity is composed with the demand for electricity for heating, but a fixed amount on demand for electricity for other end uses. So with imposing non-negativity restrictions of these quantities of the goods XE and XN, the value of the electricity for heating chosen in this maximization satisfies this demand for electricity if and only if the unconditional direct utility function is of this form, is additive in the two components of the consumption of electricity. And the implication of this formulation seems implausible because the household considers electricity for non-heating end users as a perfect substitute for electricity for heating. So the electrons could be perfect substitutes, but the utility generated by these two goods make them not be perfect substitutes because one is used for heating home, while the other one could be used for watching TV or for listening music. So this has many implications for the conditional demands and what enter the conditional demands, but also for the welfare analysis after this estimation. So these are the assumptions we use in the model. We go to the data. We have this data. We only use 3 years. We have much more years. Each year we have around 20,000 individuals. We selected a sample in which we follow individuals for 2 consecutive waves. Then we have 8,000 households. This survey provides information over 2 years, just 2 years, and interview the household in the same weeks of the 2 years to avoid things like stationality in the data. We have a lot of information, and we have a lot of information on decisions about heating equipment, purchasing of appliances, things like that, which are very important. And we have expenditures at different time frequency, and we convert everything to annual data. So this data description, these 8,000 households, 85% owned their home. Okay, this is the distribution of the household, and what we know, we don't know if its heating system is broken. We don't know things that go at the household, but we know is whether the household made savings for heating equipment in GRT -1 and whether they invested in space heating in GRT. So we can form those households in the market and estimate that. And we don't have the electricity for each of the end users, but we have information to convert expenditures in electricity for each household because we have the composition of end users at the aggregate level, at the disaggregate level, at the province level. So we do that. We have this sample in which 75% of the sample made no investment, changed the heating equipment, and 25 made investment, but only 21% of this 25% finally changed the fuel source. So these 2,098 households are those in the market, but we have also those that changed, in which we can focus for the continuous decision. So the paper contains many results on many things. So the main thing that we do is to analyze well the fuel choice, and we postulate that there should be differences between the two, those in the market and those not in the market, because of different price sensitivity, because these households have different preferences, because these households that are in the market that are more sensible to price of the electricity now, those not in the market change the heating system, we don't know when, but they are not sensible to those prices, or should not be sensible, and because of inertia, because you normally don't change your heating system, or it's more probable that you change your heating system to the same one just than to other heating system. In this sense, those not in the market should show more inertia than the rest, than those in the market. And as price responsiveness at the extensive margin, we find that there is an elasticity which is bigger on average for those in the market, for the three fuels. This is price responsiveness at the intensive margin. They are very few, so although the effects could be very large, the implication of this is that we have to get through some subsidy or whatever, trying to increase the number of households that can be every moment in the market if we like to get sensible results of the price elasticities. So the summary of findings is households in the chain group have different preferences than those in the non-chain group. Households in the chain group are more sensitive on average to fuel prices. Inertia plays a role, and a fuel choice model with inertia fit the data better. Inertia is a stronger factor in a fuel choice equation for the non-change group than for the change group. In the continuous part, households in the change group are more sensitive to fuel price in the usage of the energy services, and prices of substitutes or complements do not enter empirically our conditional demands. If you ask me for a conclusion, you can go to the last paragraph of the conclusions of the other paper and just change that to this. Given the significance of the linkage between appliance ownership and utilization decision for household energy data, we have tested and rejected, using Spanish data, that both decisions can be modeled in usual samples where a high proportion of households are not taking ownership decisions, but only utilization decisions. Thank you.
Thanks again, Jose Maria. I think I'm sticking with one question and one short answer.
Quick question, very interesting by the way. How do you deal with the fact that many people in Spain live with a central heating system in their building?
They normally are not in the sample.
Okay.
In some cases that could be in the sample, but normally not are not in the sample for estimating. In some cases they could be because we have electricity, natural gas, liquid fuels, and other sources. They could be in other sources. We do several exercises with and without. Okay.